What up? I'm the math teacher, Goat. And today in AP Precalculus, we're doing a full lesson on 2.9 Logarithmic Expressions. Logarithmic? Is that when my cabin knows how to dance? That's what I always say. Make sure you like and subscribe. Make sure you go to the description and download the notes. I like these. I like logs. They're fun. But in order for us to really fully grasp how to calculate what we're going to calculate, we're going to have a warm-up on just, regular old solving equations. Seems a little trivial, but trust me, there's a reason for everything I do. There's a reason to the madness. Solve 2x plus 5 equals 15, huh? Well, let's subtract 5. Let's subtract 5, and that gets me 2x equals 10. And let's divide 2, and let's divide 2, and x is going to equal a 5. Variables on both sides of the equal sign, eh? Well, let's subtract the one from the right because that's what I prefer doing, minus 3x from both sides. That gets me 4x plus 4 equals 20. Let's subtract 4 from both sides. Not that it's a two-stepper. 4x equals 16. Let's divide both sides by 4. Divide by 4. X equals 4. Same exact idea on this one, but we just have fractions. No big deal. NBD, let's subtract x over 2, which is like a half an x. Let's subtract x over 2, which is like a half an x. And if you have 3 halves minus a half an x, that gives you a whole x, doesn't it? A whole x, I'd rather a Rolex, right? Minus 1 equals 4. Maybe if you all like these and share these with your friends, that'll happen someday. Right now, nope. I'm stuck with the Casio. Actually, I have an Apple Watch. Let's add 1. Let's add 1. X is going to equal 5. And if you're wondering what I did here, 3 halves minus a half is 2 halves, which is a whole. Now, let's talk about some exponential equation fun. Okay? If you have, basically, when I see something like this, okay, I need to come up with a way to, you're supposed to solve. So what do? Divide by 5, take the xth root? You can't do any of that. So there's called a same base rule. That what you do is if you can write stuff so that you have the same base equals something with the same base, you set the exponents equal to each other. So I'm looking at this guy right here. 625 can be written as 5 to the 4th power. So 5 to the x equals 5 to the 4th is now the same base. What I could do is circle these and set them equal to each other, and x is going to equal 4, and that's my answer. 5 to the 4th is 625. Easy peasy. What do I do here? We'll try to do the same exact thing, okay? What I'm going to do is I'm going to rewrite 1 over 64 as 1 over 2 to the 6th, I believe that is. Yep. But I'm still not in my same base territory. It's got to be on the same level playing field. What I could do is I can rewrite 1 over 2 to the 6th as 2 to the negative 6. Now I have the same base on the same level, and x is going to equal negative 6, so x is going to equal negative 6. Okay? So you're going to deal with that a lot. Now let's talk about what a logarithm is. Okay, a logarithmic expression is the inverse of an exponential expression. So if you're wondering if you've heard of it before, or if you never saw it in Algebra 2, what a log does is it helps you solve exponential equations. Okay, a logarithmic expression is the inverse of the exponential. When you have an equation in exponential form such that b to the x equals y, you can write it out as log base b of y equals x. And you say that as the logarithm base b of y equals x. I just say log base b of y equals x. Okay, b is the base, x is the exponent, and y is your solution. Okay, so log base b equals y, or b to the x equals y, can be rewritten as log base b of y equals the x. Essentially kind of flip-flop the x and the y. And with inverses, that kind of makes sense, you flip-flopping the x and the y, if you remember what we did in the last section. Lots of flippy-floppies. Okay, like me on a grill, or me on a beach, because I wear those. Flip-flops. Hey, fun fact, if you see a log with no base, it's the same as log base 10. Okay, so if you're looking at your calculator and you're like, oh, there's a log, but there's no number. Yep, it's log base 10. One of these days I will show you a shortcut to help you out with logs that are not base 10, but we're not there quite yet. All right, so what we need to do is rewrite these in the other form. So again, let me get my colors out. We're going to have log base b of y, and let's just wrap it in parentheses to make it professional, equals x. That can be rewritten as, or vice versa, b, which I made in red, to the x equals y. As stupid as this sounds, I had a student way back when who, when I taught them this, they said, that's bx. And they were trying to say bs. And as stupid as this sounds, that's how I remember it. One throwaway comment from a senior in 2009 just made me remember all that stuff. All right, you ready? So let's do these first two by labeling things, and hopefully we can speed things up a little bit. Okay, I'm going to label u my b. I'm going to label u my x. And I'm going to label u my y. And I'm going to write that as log base b of y equals x. So this gets written as log base 3 of 81 equals 4. Just trying to move that 1 down. This is so hard. There we are. Similarly here, you're going to be my b, you're going to be my y, and you're going to be my x. So I can rewrite that as 4 to the negative second power equals 1 over 16, which is true. So now without the colors, you're my b, you're my y, you're my x. 9 squared equals 81, which is true. And you're going to be my b, and you're going to be my x, and you're going to be my y, because now I'm comparing you to you. So I would write you out as log base 10 of 0.01 equals negative 2. But you know what I just learned? I can just write it out like this. Log of 0.01 equals negative 2. All right? Now, if I'm to evaluate these, all right, there's a long way to do this and a quick way to do this, and I will show you the long way first. First off, you look kind of like u without the equals x part. So why don't I just write the equals x part? Okay, why not? I'm solving a bunch of logs, so I have to remember that log base b of y equals x can be written as b to the x equals y. So I can write this out if I call u b, and if I call u y, and x is already x, I can write this out as 2 to the I don't know equals 32. Now that takes us to the front page, where I said if you have something like this, turn 32 into a base of 2 so that we could use the same base formula. 2 to the 5th is 32. So now that I have 2 to the x equals 2 to the 5th, I can write out that x equals 5. Now technically, x was not in the original problem. So my answer is just going to be 5. So this is me being a picky math teacher. The answer is just 5. I don't think there's going to be a teacher on the planet that would say, oh, there was no x, if you were to circle that and then, do that. But since you're in AP Precalculus, chances are none of you have an x because you're all dorks. Oh, man. You got burned by a math teacher on the internet. All right, let's do it again. Set that equal to x. Call u b, call u y. Turn that into b to the x equals y. So 2 to the x equals 1 over 8. That can be written as 2 to the x equals 1 over 2 to the third. 1 over 2 to the third can be written as 2 to the negative third. 2 to the x equals 2 to the negative 3. X equals negative 3. Negative 3 is my guy. You might be saying, whoa, wait a minute. Mr. Sir, there's got to be a faster way. Mr. Math Guy, there's got to be a faster way. There is. Okay, if I give you, and let me just blow it up way up here so I can kind of demonstrate it. Okay, in purple. Basically, if you're given log base b of y, you are essentially asking yourself, b to the what power is y? That's what you're basically saying. With these answers that we got, okay, with these answers that we got, you're basically saying 2 to the what power is 32, 2 to the fifth power is 32. 2 to the what power is 1 over 8, 2 to the negative third power is 1 over 8. So this is essentially saying 2 to the what power is negative 1 over 16. Well, remember, it's going to be negative because it lives on the bottom. So it's going to be negative something. And so 2 to the what gets me 16? 2 to the 4 gets me 16. So 2 to the negative fourth gets me 1 over 16. Okay? That's log base invisible 10. So 10 to the what power gives me 100. 10 squared gives me 100. The answer is 2. 9 to the what gets me 81. 9 squared gets me 81. I'm going to rewrite this as log base 10 of a tenth. I'll write it out like u. So 10 to the 1 gets me 1 over 10 to the invisible first. Well, 10 to the negative 1 gets me 1 over 10 to the invisible first. Remember, if it's in the denominator, you're going to get a negative guy. Okay, and 10 to the first is 10. All right. Evaluate each if x equals 5. Okay, I can do this. If x equals 5, that 5 for whatever reason still lives out there. This is going to be log base 4 of 16, right? Because 5 plus 11 is 16. 4 to the what is 16? 4 squared is 16, and that 5 is still lingering out there. 5 times 2 is 10. Okay. 100 minus 20 log 10 times 5, right? 10 times 5 is going to be 50. 50 plus 50 is 100. I'm going to sneak in the invisible 10 right there so I can ask myself, 10 to the what is 100? Well, 10 to the second is 100, so log base 10 of 100 is just 2. And so I can just write out the 100, I can write out the minus, I can write out the 20. 20 times 2 is 40. 100 minus 40, 60. $600 is just lingering. 100 is just lingering. 5 times 5 is 25, and you're a 5 too. So log base 5 of 25. 5 to the what is 25? 2. 5 to the second. All of my logs became 2. Not a good job by me making these notes. But I could drop down the 600 and the 100. 100 times 2 is 200. 600 plus 200 is about 800. That's my guy. Halfway through already. Fun lesson. At least I think so. Until we get to problems like this. Logarithms are integral to understanding the Richter scale, which measures the magnitude of earthquakes. The scale is logarithmic, meaning that each whole number increases on the Richter scale represents a tenfold increase in the amplitude of a seismic wave. That's roughly 32 times more energy released by the earthquake. Hold on. So if I tell you that Los Angeles had an earthquake at 5 and San Diego had an earthquake at, why did I put it that way? San Diego had an earthquake that was 6. That this is 10 times more powerful? Yes. Yes, it is. The formula for calculating the magnitude is m equals log base 10 of a over a sub 0. A is the amplitude of the seismic waves recorded by a seismograph, and a sub 0 is a reference amplitude, the smallest detectable earthquake. That's no big deal. That's really no big deal. That's not something I want you to lose sleep over. If an earthquake has a magnitude of 6 and another has a magnitude of 7, so basically it's similar to what I just said, the second earthquake seismic waves are 10 times larger and it releases about 32 times more energy than the first one. Don't worry about the 32, it's the 10 times that we need to worry about. Thank you, ChatGPT, for the reference. Now, let's use the scale below to answer these questions, okay? Let's use the scale below to answer the questions. Which statement most accurately describes how much more intense earthquake C was more than earthquake A? So these guys, every one tick of these is going to be 10 times more. All right, so basically if you're comparing earthquake C with earthquake A, we need to find out what 10 to the C minus A is. Okay, it's not just a matter of saying the answer is 5, because that's not true. It's 10 times more. Every one is 10 times more. C being the larger, minus A being the smaller. And in this case, we're talking about C and A. I'm just using those numbers. Okay, so 10 to the C minus A is going to be 10 to the 8.5 minus 3.5, which is 10 to the 5th, which is 1, 2, 3, 4, 5. So it's 100,000 times more powerful, which is crazy. But it looks like they just want us to say 10 to the 5th times more intense. Okay? So that 8.5 is not 5 times more, it's 100,000 times more. Crazy. Crazy stuff. Okay, so we're using the same exact picture. Can I fit it all in? No, not really. Now I can. Which of the following statements is true? The intensity from earthquake A to B is greater, okay, than the intensity from earthquake B to C. So they want us to compare A to B to B to C, it looks like. So, all right, so let's do A to B. A to B is going to be 10 to the 6.0 minus 3.5, which equals 10 to the 2.5. And I did A to C, so I don't need to worry about that. B to C is going to be 10 to the 8.5 minus 6.0, so the same thing. So 10 to the 2.5, the same thing. So the increase in intensity from A to B is greater than the increase in intensity from B to C. Nope. The increase in intensity from earthquake A to B is less than, earthquake A to B is less than the increase in, nope. Earthquake B is as many times more intense to earthquake A as earthquake C is as many times more to intense to, yes, to B. Ooh, My Singing Monsters. Do the earthquake. Remember that? If you don't know what I'm talking about, watch videos on My Singing Monsters. My twins, who are now 10 in 2025, used to play those games all the time, and I've recently fell back in love with them. I don't know why. They're unbelievably stupid. 5 to the what power equals 1? Well, anything to the 0th power equals 1, so 0. Make sense? 5 to the 0th power equals 1. Anything other than 0 to the 0th power equals 1. Solve for x. All right, so remember, log base b of y equals x can be written as b to the x equals y. So you're in logarithmic form, so you're my b. This is annoying. You're my y, and you're my x. So y is x. As dumb as that sounds, that's no big deal. I just have to write it out as -2. Nope, 5 to the -2. 5 to the -2 is going to equal x. That can be written out as 1 over 5 squared equals x. And that can be written as 1 over 25 equals x, which means x equals 1 over 25. Log base 2 of x minus log base 2 of 8 equals 3. Now in the future you will learn a shortcut to handle something like this, but I don't know the shortcut yet. So all I can do is say log base 2 of x, I don't know, log base 2 of x. Oh, 2 to the what power is 8? 2 to the third power is 8, so minus 3 equals 3. Okay. Add 3, cross you out. Log base 2 of x equals 6. Now I'm in business. Now I can write this out the other way. This is basically now saying 2, if I were to write this out in logarithmic form, exponential form, you would be my b, you would be my y, you would be my x. So b to the x is 2 to the 6 equals x. 2 to the 6 is 64 equals x. So x equals 64. Okay? Last but not least, I believe, log base invisible 10 of x squared equals 4, and I need to solve it, so let's put it in the other form. Okay, I have to put it in as your b, your y, your x. So 10 to the 4th is going to equal x squared. 10 to the 4th is 1,000. That equals x squared. Square root both sides to solve for x. Don't forget your plus or minus. And the square root of, oh, did I miss a 0? I did. I did miss a 0. I did miss a 0. I knew something wasn't right there. Ooh. The square root of 100, or no, 10,000 is just 100. So I have a positive or negative, 100 equals x. So x equals positive or negative 100. They, of course, don't want me to write it out that way. They want me to overcomplicate things and keep it in its exponential form. No big deal, NBD. Logs, I love them. I'm a huge fan of logs, okay? So that's a short and sweet lesson. And the next couple lessons are fun too, because like I said, I really enjoy logarithmic functions. I don't know what's wrong with me. Please like and subscribe. Make sure that you go to my YouTube and type out AP Precalculus 2.9, and you'll see a bunch of my random videos that has to do with what we just learned. It's just random stuff that I made that might help further your knowledge, further your understanding, stuff that I may not have covered in class, but might show up like on an exam or an AP thing or something like that, that just might help you out a little bit more. All right, but that's all I've got. Short and sweet lesson. Thanks for watching. Love you. Bye.
Hey, hey, hey.